Hello, my name is Ritisha Kiran, and today I'll be going over Module 6, Question 2 for the Logistic Regression Assumptions assignment for Advanced Statistics HAP 719. In today's presentation, I'll just be going over the study background first, in which we'll analyze how the medical foster home, which stands for MFH program, relates to 6-month survival in elderly patients. We'll be using logistic regression to explore this relationships. The study uses a data set that includes patients' age, gender, and various disability indicators derived from the CSS diagnostic codes. In this assignment, disabilities are measured probabilistically. If a value exceeds 0.5, the patient is considered to have the disability. Our main goal is to determine whether MFH enrollment and functional status predict survival in geriatric settings. So just to want to reiterate that if a value exceeds 0.5, the patient is considered to have the disability. So first, I'd like to go over the different survival variables. The data set includes 2 measures of survival. Death 6M is a binary variable that tells us if the patient died within 6 months. 1 equals yes, and 0 will equal no when we get the coding answer. And days to death records the number of days a patient lived before dying. This value is blank for patients still alive. Each disability will end in _365, representing limitations over the past year. These disability scores were generated using predictive models and then converting into binary form. If the score was above 0.5, indicating a likely disability, and 0 otherwise. And these different disability scores were generated using CCS codes and demographic data through predictive modeling. So the first part of this assignment is just making sure to clean the data, which we'll be receiving as an mfh.csv file, which I'll be attaching below for the instructions. To clean the data, I first converted the age column to a numeric format and created a new variable, age_decade, which is just divided by 10. I'm going to go ahead and show my R code here. So for step 1, I remove the rows. This is just my code where age is missing or not numeric. I like to convert age to numeric and create age in decades by dividing by 10. Then I'd like to identify all the disability columns, making sure they're true, and convert the disability scores to binary numbers, giving them if X is greater than 0.5, 1 or 0 label. Remove rows with any missing values and key variables, convert gender to factors, and then just overall run this to give me the clean data. And then now this clean data set is ready for regression analysis. So if it is assigned a value of 1 and the probability goes greater than 0.5, this indicates that the person likely has a disability, and 0 otherwise. So we load the libraries, read R to read the data set, and dplyr to clean and manipulate the data. And this I went over in R and how to get the different types of clean data. So question 2, now we go over the regression model. So we ran a logistic regression model to predict survival using 4 predictors, and the 4 most important predictors in the next 6 months based on patient characteristics and disabilities. And the most important came out to be the enrollment in MFH program, age, measured in decades, bowl incontinence. So patients with bowl incontinence as a disability had higher odds of survival. Dressing Disability. Patients that needed help with dressing was associated with a lower chance of survival, likely because it reflects greater frailty or functional decline. And bowl incontinence surprisingly increased the odds of survival, possibly due to more frequent care or monitoring. Overall, the model shows that clinical needs and access to supportive care significantly influence short-term survival in elderly patients. So this R code was able to run the logistic regression, and this estimates how each predictor affects the log odds of surviving the next 6 months. This was able to provide us the coefficients and p-values to determine significance. And the different significant codes were measured from 0 to 1. So the MFH enrollment had a beta value of 2.76 and was able to give us a strong positive predictor. The age in decades had a beta value of 0.06 and was smaller, but it was a significant effect. Bowl incontinence had a positive predictor, and dressing disability had a strong negative predictor. Along with this, I would like to conduct the likelihood test, which helps us evaluate whether the model with predictors performs better than a model with no predictors. The null deviance was 1393.8, which assumes that no predictors were used. The full model deviance shows us that after adding MFH, age, and the disability indicators, it dropped. The difference in deviance is 294.9 over 13 degrees of freedom. The p-value is extremely small, less than 0.001. This means our full model is statistically more better at predicting survival than a model with no predictors at all. So in general, our selected variables, especially MFH enrollment, significantly improves our ability to predict who survives. This gives strong statistical support for including these predictors in care planning models. And this is the R code that I used for the likelihood ratio test. So our top 4 predictors of survival first start off with the most strongest positive, then go on to age. Older age slightly improves survival odds. Bowl incontinence is a positive indicator likely due to increased monitoring, and dressing disability is a strong negative predictor that indicates frailty. So we use the summary model to display output like coefficient Z values and P values, which we have ran over here. Convert columns, disabilities to binary, convert categorical. And this was the code that I used in order to get the different values so that I would be able to come up with the top 4 predictors of survival. And this was my analysis that I was able to get from each of the top 4 predictor values that each fall within the 0.5, 0.0.5 significance value. These results can help guide interventions in senior care by targeting modifiable risks and improving support systems like MFH. So the overall question here was, does MFH contribute to survival? And yes, after a lot of regression analysis, I can say that it does contribute to survival as the coefficient for MFH is 2.763 with a p-value less than 0.001. And this indicates that patients in the MFH program has significantly higher odds of surviving the next 6 months. It is likely to reflect the structured care, supervision, and stable environment provided by the program. And this is what I ran in order to get the coefficient value and the p-value and the different estimates and error values. All predictors were statistically significant with p-values well below 0.001, confirming that they are strong factors. So, in order to wrap this up, I would just like to acknowledge that MFH enrollment significantly improves short-term survival, especially in elderly geriatric patients. And it is important to keep this in mind, and using regression modeling is an important way to be able to see this on how patients are able to survive. Functional disabilities, especially dressing and bowl control, are key survival indicators. These are two important factors. Being able to dress yourself and use the bathroom are really important factors, which determine survival and disability rates. Logistic regression is a powerful tool for analyzing these binary outcomes like survival. These findings support the value of MFH programs and highlight areas where care teams can intervene to improve outcomes. I do believe that there should be stronger support systems that continue implementation of the MFH programs in geriatric care. Thank you.